So I'm not going to do too much of an intro, Vikas, other than you've been in IT for 15 years, a lot of different roles, probably most recently in the QA space. And he's going to talk about debunk the biases in software development. So, Vikas, the
Thanks.
floor is yours.
Can we just make
Uh,
sure everybody's muted? I hear weird noises going on.
We'll let our host make sure that that happens.
Sounds good. So yeah, if everyone can get muted, that would be nice. So everyone can just hear me. Good afternoon, everyone. Thank you for joining us for this talk today. Before we start with the presentation today, I just wanted to take a moment to thank both Dhaka and KCQA for working together and organizing this event. And thanks, Tom, for providing a brief introduction. I'll also go a little bit more, maybe share some facts that a lot of people may not know about me. Um, as you already know, as many of you might already know, I currently work as a manager at Sageti and have been with the company for almost a year and a half now. And I started my career as a QA professional in a health insurance company, and subsequently I worked in a few different industries, in a few different geographic locations in North America, both Canada and US, and worked in quite a few different roles such as QA, BA, and developer. And I would like to say that it has been a really nice learning and educational experience working with all the awesome folks that I got an opportunity to work with. So yeah, having said that, as far as the presentation for today's concerned, as all of you know, I'll be talking about biases and their impact on software development. I was originally planning to talk only about biases and QA, but I figured it might be useful to incorporate some examples that are related to software development in general. And of course, I'll also be referring to a few non-IT examples too as a whole, uh, you know, um, as and where it makes sense, because I think some of the examples, non-IT examples, are really useful to elaborate on some of the concepts. So yeah. As far as the agenda for the presentation today is concerned, I'll be talking about a few different types of biases, some of the examples of the biases in software development, and a few of the steps that can be taken to overcome the biases. And finally, we can have a Q&A session. So, yep, that's the plan for today. If you have attended some of my previous presentations, you might have noticed that I usually like to go over some of the basic definitions, some of the basic concepts before I get started. Anyways, bias. What is a bias? Bias is a disproportionate weight in favor of or against an idea or a thing. This can be the results of folks being close-minded, prejudicial, or unfair. Also, biases can be innate or they can be learned. People may develop biases for or against an individual, a group, or a belief. In terms of science and engineering, a bias is a systematic error. In a sense, being biased simply means being systematically wrong in a way or another. There are, of course, a few different types of biases. The first one, the cognitive bias, and that's the bias that I'm going to be covering a little bit more in the subsequent slides today. So I won't cover that right now. Then there's, of course, the conflict of interest, conflict of interest bias. A conflict of interest is when a person or an association has intersecting interests which could potentially be corrupt. Some of the conflicts of interest are bribery, favoritism, lobbying, regulatory issues, or shilling. Statistical bias is a systematic tendency in the process of data collection, resulting in lopsided and misleading results. This can occur in any number of ways, in the way sample is selected or in the way data is collected and so on. It is a property of a statistical technique or its results whereby the expected value of the results differs from the true underlying quantitative parameter being estimated. And statistical bias results from unfair sampling of population or from estimation process that does not give an accurate result on the average. Some of the common statistical biases are forecast bias, observer expectancy effect, report bias, social desirability bias, and selection bias. Finally, prejudices. Bias and prejudice are usually considered to be closely related. Prejudice is prejudgment or forming of an opinion before becoming aware of the relevant facts of a case. The word is often used to refer to preconceived and unfavorable judgments towards people or a person because of factors such as gender, political opinion, class, age, disability, religion, or other personal characteristics. Prejudice can also refer to unfounded beliefs and may include any unreasonable attitude that is usually resistant to rational influence. Cognitive bias. So, what does the word cognitive mean? According to Merriam-Webster, cognitive refers to something of relating to or being or involving conscious intellectual activity such as thinking, reasoning, or remembering. This leads to the next question. What is cognitive bias? Cognitive bias is the repeating of or a basic misstep in thinking, assessing, recollecting, or other cognitive processes. In other words, it refers to a pattern of deviation from standards in judgment, whereby interferences may create unreasonability, may be created unreasonably. Thus, cognitive biases may sometimes lead to uh, perceptual distortion, inaccurate judgment, illogical interpretation, or what is broadly called irrationality. I would, however, like to point out that although it may seem like misconceptions would be aberrations, biases can sometimes help people find commonalities and shortcuts to assist in the navigation of common situations in life. In essence, many of these biases serve as adaptive purpose and allow us to reach decision quickly. This can be vital if we are facing a dangerous or threatening situation. As an example, if you're walking down a dark alley and spot a dark shadow that may seem to be following you, a cognitive bias may lead you to assume that it's a mugger and you need to exit the alley as quickly as possible. The dark shadow may simply have been caused by flag waving or in the breeze, but relying on the mental shortcuts can often get you out of danger in situations where decisions need to be made quickly. And as I mentioned before, cognitive biases are the main theme of today's talk. So I'll be talking about some of the specific cognitive biases shortly. Your tech is as biased as you. Before I dive more into cognitive biases, I wanted to talk about biases in technology since we are talking about software development too. I recently came across some material that talked about bias in technology, and it just felt right to include a slide about that in this presentation. I'll begin by defining algorithmic bias, which in essence describes systematic and repeatable errors in a computer system that can create unfair outcomes, such as privileging one arbitrary group of users over the others. Bias can emerge due to many factors, including but not limited to the design of algorithms. It can also be unintended or unanticipated use or decisions relating to the way the data is coded, collected, selected, or used to train the algorithm. The human biases can significantly impact the intelligence systems and can creep into algorithms in many ways. One source of bias is the flawed data sampling, in which the group is over or underrepresented in the training data. For example, in one of the facial analysis technologies, there were significantly higher error rates for minorities, particularly minority women, potentially due to the under, unrepresentative training data. Additionally, AI systems learn to make decisions based on training data, which can include biased human decisions or reflect historical or social inequities. This happens if sensitive variables such as gender or race are removed. As an example, Amazon built an AI-based hiring system in 2014 but that tool was biased in favor of males. Since it was mostly males involved in the learning process, the system looked for keywords that were used more so used by males. A couple of such example words were executed and captured. Eventually, Amazon had to stop using the tool, and just because of such kind of bias that was incorporated in that. Naturally, unconscious bias is a problem that impacts all. As far as the AI systems are concerned, the progress made to address the bias needs to be accelerated so they don't have significant impacts on technologies used for business. The challenge of avoiding bias. According to Daniel Kahneman, Dan Lovello, and Olivier Siboni, people can't do much about their biases and they are incapable of recognizing them. Now, the three folks that I've talked about, they actually wrote a paper on cognitive bias, and it was kind of an interesting read. Cognitive scientists believe that there are two modes of thinking, intuitive and reflective. In intuitive or system one, thinkings, impressions, feelings, intentions, and preparations for actions, for actions are effortless. System one produces a constant representation of the world around us, allows us to do things like walk, avoid obstacles, and contemplate something else. You know, all at the same time. Basically, just as the name suggests, being intuitive. We are in this mode when we brush our teeth, banter with our friends, or play tennis. We are not necessarily consciously focusing on how to do these things. We just do them. They just come naturally to us. In contrast, reflective or system two thinking is slow, effortless, and deliberate. This mode is at work when we complete a tax form or learn how to drive. Both modes are continuously active, but system two is just typically monitoring things. It's mobilized when stakes are high, when we detect obvious error, or when rule-based reasoning is required. But most of them, system one, most of the times, system one determines our thoughts. Because system one is good at making contextual stories and we are not aware of its operations, it can lead us astray. The story that it creates are generally accurate, but there are exceptions. An insidious feature of cognitive failures is that we have no way of knowing that they are happening. Many times we are not able to control our intuition, but we can rationally apply thoughts to detect others for faulty intuition and improve on their judgment. So while basically we may not be able to do anything about ourselves, but within a team or as leaders, we might be able to uh, detect others in faulty intuition and improve on their judgment. So in essence, Kahneman and Lovello and Sibani believe that most folks can't do much about their biases, but given the right tools, they can recognize and neutralize those of their teams. As far as cognitive biases are concerned, there are quite a few of them. Some of them are displayed in this picture. Some of the most common biases are the confirmation bias, the anchoring bias, the bandwagon effect, and so on. The question is, why do people have these cognitive biases? If you have to think about every possible option when making a decision, it would take a lot of time to make some of the even simplest choices because of the sheer complexity of the world around us and the amount of information in the environment. It is necessary to rely on some of the mental shortcuts that can help us act quickly. Cognitive biases are caused by a number of different things, but it is in these mental shortcuts known as heuristics that often play a major contributing role. While they can often be surprisingly accurate, they can also lead us to have errors in thinking. Some of the other factors that can contribute to these biases are emotions, individual motivations, limits on the mind's ability to process information, and lastly, social pressures. In this presentation, I'll focus on a few of these and their impact in general and also in software development. The first bias we'll be looking today is the anchoring bias. So what is anchoring bias? Anchoring bias is the tendency to rely heavily on the first piece of information that is offered or provided to us. The first piece of information usually acts as an anchor and influences our decision making. Anchoring bias is one of the most robust effects in psychology. Many studies have confirmed its effects and shown that we can often become anchored by the values that aren't even relevant to the task at hand. In one of the studies, for example, people were asked for the last two digits of their social security number. They were subsequently shown a number of different products, including things like computer equipments, bottles of wine, boxes of chocolate, and things like that. For each, participants were asked to indicate whether they would be willing to pay an amount of money formed by the two digits of social security number. For example, if someone's number ended in 34, they would say whether or not they would pay $34 for each of them. After that, researchers asked them what's the maximum amount that each participant was willing to pay. And even though someone's social security number is nothing more than a random series of numbers, these numbers had an effect on their decision making. So, for example, people with digits amounted to a higher number were willing to pay significantly more for the same product compared to those with lower numbers. Anchoring bias also holds up when anchors are obtained by rolling some dice or spinning a wheel. And when researchers remind people that the anchor is irrelevant, then also it can have an impact on people. Essentially, there are three types of anchoring bias. The first one is a classic case where the initial estimates, which are usually best guesses, are used and their accuracy is not challenged. Another type of anchoring bias is the estimates based on the extrapolation from history. Finally, the third type of anchoring bias is a deliberate one, which can be caused to favor certain agenda or something like that. One of the most common examples of anchoring bias in software development and also beyond is salary negotiation. The company trying to hire a resource will try to offer a base salary lower than what they are willing to offer, and the interviewee will try to ask for a base salary higher than what they are willing to pay. Another example involves story pointing in sprint planning. If someone has a lot of experience working on tasks related to the user story and they provide lower story points first, it might anchor others to provide lower value for that story, regardless of whether they themselves can complete can use that particular story points for completing that work. So, and on the other hand, someone who has less experience might provide a higher anchor if they are the first one to estimate. And interestingly, this morning I was reading an article which actually said that the person who makes it might actually be in best interest of an individual to actually be the first one to anchor a value, especially if you are in a salary negotiation. That's something usually that's not recommended, but this particular report said that if you are the first person to provide an anchor, you might be at an advantage. So how do you debunk the anchoring bias? The idea is to adjust the estimates after re-anchoring, especially if the original recommendation seems to have been anchored by initial estimates and the number in question has quite a bit of material impact. The idea here is that seeking others' opinions or getting more information from them might also help. It can allow one to view the problem from a different perspective and allow them to use alternative starting points. This allows the team or individuals to widen one's knowledge, the frame of reference, as well as push the mind in different directions. The important suggestion is here is not to stick to the first line of thought. One of the questions to ask while debunking the anchoring bias is if you know where the numbers come from. Another question is which numbers are facts and which numbers are estimates. Lastly, is there any specific motivation to use an anchor? Some folks providing an anchor might have a specific agenda of their own. Um, can you guys hear me?
We can now. You dropped off for a bit and even I think lost connection.
Okay. Sorry about that. So I was talking about confirmation bias. Can you see my screen?
Yes, we can.
Okay, sounds good. So I was talking about confirmation bias, and I was saying that people who support a particular or oppose a particular issue will not only seek information that support it, they will also interpret. Sorry, is there any someone said something? I thought I heard anything. Anyways, so they will actually also interpret news items in a way that upholds their existing ideas. They'll also remember details in a way that reinforces these attitudes. As a result of confirmation bias, two people may have very different opinions on the same subject, and their interpretations will be based on their beliefs. So even if they read same story, their bias tends to shape the way they perceive the details, further confirming their beliefs. Unfortunately, this type of bias can prevent us from looking at situations objectively. It can also influence the decisions we make that lead to poor or faulty choices. As an example, during the season, for example, people tend to seek positive information that paints their favorite candidates in a good light. They will also look for information that casts the opposing candidate in a negative light, and that's quite a popular effect during the elections. As an example of confirmation bias in software development and testing, let's say Peter is a tester and works with two developers, Jim and John. People strongly believe that Jim is a developer and his work is never up to mark. He feels that Jim is a better developer than John. Peter would subsequently find evidence to back his opinion and test John's code very thoroughly to find several issues. However, during the process, he may ignore good parts of John's work and also favor less on Jim's work, leading to issues in Jim's modules. Another example, if you look at unit tests of a given project, they will often test how the code should work instead of trying to catch possible mistakes and failures. Confirming that the code is doing what it's intended to do is good enough for us, but most of the time, but it's not good enough many times, as most of us have learned in our testing from a negative perspective to not just to confirm our are biased towards, how the system should work in a normal way. Debunking the confirmation bias. One of the ways to debunk the confirmation bias is to use devil's advocate on the team, someone who would speak up against the thinking that leads towards preconceptions or opinions. I also came across the term 10th man rule in a science fiction movie that I watched a few months ago. According to this rule, if nine people agree on one thing, the 10th person should be appointed to speak up on alternatives or something that opposes what the nine people agree on. Anyone has any idea of which movie I'm referring to?
Looks like we lost Vikas again. Hopefully he'll get rejoined.
My apologies about that. I'm sorry, the internet is not working nicely with me. Can you guys see my screen?
Yep, we've got you, Vikas.
So I'm not sure where I got dropped off. I'll start talking about debunking again. Debunking the confirmation bias. So one way to debunk the confirmation bias is to use the devil's advocate in the team, someone who would speak up against the thinking that leads towards preconceptions or opinions. And then, of course, on a related note, there's the concept of the 10th man rule, where if nine people agree on one thing, the 10th person should be appointed to speak up on the alternatives or something that's opposite of what the nine people agree on. Another way to overcome the confirmation bias is to look at the data holistically. While doing that, it's essential to look for evidence that disproves your point of view and make decision only after taking into account all the facts. As the saying goes, a half truth is even more dangerous than a lie. One of the questions to ask while debunking the confirmation bias is whether credible alternatives have been considered. In essence, that have at least one or two alternatives have been considered with pros and cons. Another question to ask is whether is what exactly the alternatives were considered and when were they discarded, why were they discarded. Finally, did you actively consider information that would disprove the main hypothesis, or the information only confirms with the evidence in the final recommendation? The next bias that we'll look at is the bandwagon effect. Bandwagon effect is a cognitive bias or psychological phenomenon that causes people to think or act in a certain manner because they believe that other people are doing the same. As an example, the bandwagon effect may cause someone to adopt a certain political ideology simply because influential people in their social circle have adopted the same ideology. in the process of adopting what everyone else is doing, people often neglect the personal preference or underlying evidence. They naturally tend to avoid complex information processing and decision making by relying on others' actions. This tendency of people to align their beliefs and behaviors with those of a particular group is called herd mentality. The bandwagon effect arises from psychological, sociological, and to some extent economic factors. People like to be on the winning side of the team, and they like to signal their social identity accordingly. Economically, some amount of bandwagon effect can make sense in that it allows people to economize on the cost of gathering information by relying on the knowledge and opinions of other people. The bandwagon effect permeates many aspects of life, from stock markets to to clothing trends and to sport fandom. While this may be a very talked about bias, I felt based on my research that this wasn't as much studied. Um, One of the examples of bandwagon is tool or technology selection in software development. As an example, in test automation, the team might be tempted to select a set of tools just because many other QA organizations are doing. Uh, in in some sense, it might be fine, but in other situations, the tools may not necessarily be appropriate for the team. Another example that I came across that I thought was interesting and occurs many times in software shops is uncritically agreeing to a senior member's suggestion. That can be a team lead or a senior developer or a senior tester. That sometimes occurs when alternatives are not considered and people just follow what the senior person is saying. In terms of overcoming or minimizing the effects of bandwagon effect, one way is to slow down our decision making process, allowing some time to pass between when we notice the social signal and our final decision. It can allow for critical thinking and prevent us from quickly adopting an idea that's popular or that's common among other teams or other group of people. Secondly, we can try to overcome, we can try to make decisions in an environment where you don't feel pressured by what other people are doing. Another way is to cross-check the validity of any information which can be useful and necessary. Asking the source or checking with other sources might help us reach a more credible conclusion. Promoting open-mindedness can also be helpful. We cannot use past actions as an example. Mentally think thoughts like he would not do something like that or it has never happened before should be avoided. Lastly, consider alternate options before that go against the majority view. They may they may prove to be beneficial or at least mitigate the effect of what's going on with the prevailing sentiment. Availability bias. The availability bias is the tendency to make judgments about the likelihood of an event based on the readily available examples in our mind. As an example, we might assume that the most number of deaths caused last year in the United States were due to COVID-19. This is because of all the news stories that we see about COVID-19. We may judge the likelihood of deaths due to COVID-19 to be greater. The fact that heart diseases have caused more deaths in the US than COVID-19 last year might go against what we see as an example. The availability bias results from a cognitive shortcut known as availability heuristic, defined as the reliance on those things which we immediately think of to enable quick decisions and judgments. That reliance helps us avoid laborious fact checking and analysis, but increases the likelihood that our decisions will be flawed. As an example, the development team and the management team feels that there are a lot of issues showing up in production just by recalling a couple of examples of production issues that they may judge that they may start judging the tester and feel that their work is not up to mark. The fact that the tester never leaked a bug to the production in last 6 months and always did a great job, maybe disregarded just because of one or two defects. The development team and the management teams in this case are victims of availability bias, and it's a very common scene to put a blame game on the testing team when things go in production. It's not very uncommon for that to happen. On the flip side, another example can be when testers find a few defects in the in-sprint testing, and they start blaming the developers for poor quality of the software without giving a regard to the complexity of the system or prior performance of the developers. One way to overcome the availability bias is to look at the information over a period of time. That's going to provide a more accurate information than a small amount of data to make better judgments. Another way is to have some people who play devil's advocate, or have a team with diverse skills and background where people often challenge each other to think rationally. Plunging in bias. Plunging in bias refers to the act of starting to solve a problem before understanding or even considering the best ways to address it. Good people can sometimes fall into the trap and can make bad decisions because they didn't follow the right approach. Now, in terms of plunging in bias, it's not a very well-known bias, and has almost received no attention by very limited or no attention by researchers, strategy educators, or even business writers. Um, Generally, if you can overcome the plunging in bias, including errors of omissions, you can make better decisions. Plunging in our bias can be manifested in many ways. One, we often assume that we understand the problem and move on to the tasks required to solve it. This is especially likely under time pressure or in emotional circumstances. Secondly, we take the problem given to us and don't question its validity. We assume the way it has been stated is correct and complete. Thirdly, we use a broad label or keyword example for as an example, turnaround, growth, and so on, to describe a problem rather than a story that captures the essential contours that make it different. For example, when Apple and the movie studio Paramount both face declining sales, the contours of the problem are different for each of them. Due to these tendencies, important aspects of problems are missed, and they're solved inadequately. At times, the word problem the word problem does get solved, but not all the times. One of the examples of plunging in bias in software development is when developers start coding without thinking through or designing. This usually happens more often with the junior developers, and as tempting as it is, it can have not so nice consequences. And again, even though I say happens more with junior developers, it can happen even with some of the senior folks sometimes. Another example is when testers open defects without giving consideration to all the facts. I've done it myself when I started my career initially in testing, and of course, I do less of that now. Now that I've matured more, and I now have a better understanding of the testing process. Again, this is the same concept as developers starting to code without thinking through. Same concept applies here with testers also. As for overcoming the plunging in bias, there are three frameworks provided that can be beneficial: problem facetting framework, who what matrix, and the quotient tree. I will not go into a lot of details. It can be Google and more research can be found, but I'll go briefly over these. The problem faceting framework talks about five facets that help to help overcome the or better look at the problem. The accomplishment gap, hurdles, enablers, time, and core questions. To articulate accomplishment gap requires realistic understanding of the present and the ability to envision compelling future. Hurdles, which what is preventing from going from where we currently are to where we want to be. Enablers, what can help us to get to where we want to be. Time, time is often missing element in problem solving and addresses things like whether the problem can be solved in 6 months or 10 years. Finally, the core question. You put all things together and frame the problem as a question so that it's a hypothesis. As for the who what matrix, most problems cannot be solved by one person or organization. You have to take into account other players who can be individuals or organizations. These can be players you want to include in problem solving or take into account because the results impact them. As an example, hospital systems should consider how their problem solving efforts affect patients' families in addition to the patients themselves. By including wider set of people, the what metrics can help create trust, commitment, and a sense of procedural justice, and subsequent increase the likelihood of success. Finally, the question tree reminds you to think of things that you may not have thought about. It's about elevating the errors of omissions. In essence, how we tackle the problem before we're tackling it. What question should we be asking? Sunk cost bias. Sunk cost bias is our tendency to continue investing in losing proposition what it's already cost us, because of what it's already cost us. Needless to say that we can fall prey to sunk cost bias because we are all innately loss averse. And let's be honest, who wants to take a loss and admit that they wasted money, energy, and years of their life that could have been better spent? Biting the bullet and acknowledging that our choice to invest in something else that is no longer serving us is difficult. It is probably why people stay in their careers a lot. It's why smart people stick with blindingly obvious bad investments for far too long, clinging in with blind optimism. It's why it's like saying why I kept those shoes so long, and you likely have a few things in your wardrobe right now. If you had the choice to buy them again, why you wouldn't? As an example, in software development, a feature to be built has work done in terms of user research, prototyping, user testing. The team later finds that the feature is not widely demanded or not well understood, or perhaps it just doesn't deliver the value compared to the overall development cost. All the employee times and the salaries are sunk cost. The team might, regardless, continue doing more research, redefining the scope, developing the feature, and going into production. Reasons are plentiful, ranging from the fear of wasting the resources, hoping you can flip into success, to simply being in love with the idea. Another interesting example that I came across for this bias is the building of the supersonic plane Concorde. Already in the early development stages, the costs rose higher than expected, and the financial success financial success was unclear. Nevertheless, the project was not stopped but further funded because of the amount of money that was already invested. So how do you overcome the sunk cost bias? One way is to iterate and fail faster. In Scrum type processes, ceremonies like retrospective do a better job than traditional waterfall methods due to the faster time to market delivery. Luckily, the development team can be avoided from the beginning. The development work can be avoided from the beginning if the if there's any problems that can be foreseen in advance. Um, so from that perspective, it might be helpful to to iterate and fail faster. Another way is to validate frequently with stakeholders. Again, Scrum ceremonies like sprint and reviews and with the business can help with the feedback to come through early on. Finally, when the problems are noticed, while there's a lot of work has already been done, one should look for other alternatives and options and evaluate their future potential, ignoring the sunk cost. And I would say highlight the words ignoring the sunk cost. Sunk cost. In conclusion, I would say that cognitive biases can lead to distorted thinking. Although cognitive biases are not all necessarily bad, psychologists believe many of these biases serve an adaptive purpose. They allow us to reach decisions quickly. They can be vital if we are facing a dangerous or threatening situation, like the early example I gave before. There are techniques available to overcome the adverse effects of cognitive biases. Research also suggests that cognitive training can help minimize cognitive biases in thinking. Reducing cognitive bias may also be beneficial in the treatment of some mental health conditions. Cognitive bias modification therapy, or CBMT, is a treatment approach based on processes that are designated that are designed to reduce cognitive bias. This form of therapy has been used to help treat addictions, depression, and anxiety. And that's essentially what I have for today. Um, any questions?
If anybody's got any questions, feel free to unmute yourself and just ask, or post your questions in the chat for Vikas. And great presentation so far.
Hey, Vikas. Is there a particular bias that maybe occurs more than another one in your research?
I think confirmation bias and anchoring biases, these are the most common ones. Specifically, the confirmation bias it's more prevalent and more common than some of the others.
I've got a question. This is Andrea. I wonder if you've had experience with some of these biases. I think we've probably all experienced either being new on a project or having a new person join a team, and they see bugs that we've kind of become blind to maybe ourselves because of some of these biases. I wonder if you have any experience, like one thing I've wondered about is kind of rotating QA personnel on teams or projects, or to do exploratory testing or things like that. Just getting some fresh eyes on things sometimes helps alleviate some of these biases, maybe.
I totally agree with that. One of the things that I encourage on my team is of course, the QA resources and other people within the team do the testing, but bring people from other teams, like you suggested, who have practically no exposure to what went through the project and all the decisions and everything, and have them, test without any prior information. Just give them basic information like login information, how to log in and things like that. But
Mm-hmm.
other than that, have them, test it. And a lot of times, uh, things, defects, especially from a usability perspective, and some of the other major bugs can also be founded through that kind of process.
Cool.
And I apologize for the internet problems I was having. I usually don't have them, but somehow today, when I need to do this presentation, the internet wasn't helping me out. So yeah, I apologize for that. Anyone have any other questions? If not, then I don't know if there's Dusty, Tom. Do you have anything else for now?
I do not. I want to say thank you. It was good information. I took quite a few notes. I appreciate your time.
Thanks.
I just,
I'll
I was
share.
just going to say,
I'm
oh,
sorry, go ahead.
sorry, Vikas. I
No,
just wanted to say, I just wanted to say thank you to our sponsor this month, Global Tech Services. And Aubrey or Mike, if you wanted to say something quick before we go, give us a quick
Yeah,
spiel about GTS.
yeah. We don't need to go over it super much, but yeah, thanks Vikas and thanks DACA and everybody for joining today. But yeah, just we're Global Tech Services. We're in Des Moines. We've been here for about 20 years. We're women owned. But yeah, just great topic today, and thanks for having us.
And Dusty, Tom, I'm going to share the presentation with you so you can pass it along to everyone.
This we'll make available your slides, and this presentation's been recorded, so both of those will be available on our website, and I'll share that with Tom and KCQAA as well, or KCQAA, and make sure everybody gets that.
Wonderful.
Thank you.
All right. Have a great Thursday, everybody. Thanks.
Thank you.
Thank
Thanks,
you.
everybody.
Thank you.